Hey, it's OG Math Mosley, and today we're going to be talking about fractions and fraction operations. All right, so let's get started. All right, so this will be a review of fractions and fraction operations. Hopefully this is something you've seen in the past, and you're just trying to brush up on it or remember things you may have forgotten. I'm not going to go super in-depth, but will be a good review. Right, so what is a fraction? It's a good place to start. Right, a fraction is a number. It tells you how many parts of a whole you have. Right? For example, we have these circles being broken up into parts. The first one is 1, because you have one part of a whole where it's only been broken up into one part. The next is 1/2, where we have one part of 2 pieces. A quarter, we have one part out of 4 pieces. 3/4, we have 3 parts out of 4 possible pieces. So we can break a thing into multiple parts equally, and the fraction tells us how many of those multiple parts we have. Right? A fraction is made up of 2 parts. We have the numerator and the denominator. Here we see the 3, the number on top, is the numerator, and the 5, the number on bottom, is the denominator. So we have those two special terms when we're talking about fractions or things written as fractions. We have the numerator, the top part, the denominator, the bottom part. Continuing on, what is a fraction? Again, we have our numerator, denominator, a over b. The little bar there is the fractional bar. The numerator is the top number of a fraction and tells you how many parts of the whole you have. The denominator, right, is the bottom number. Again, this guy here tells you how many equal parts of the whole is divided into. Okay, so how many parts of the whole that I have, how many parts are possible. Fractions can also be referred to as rational numbers. Right, rational numbers is a more broad term in mathematics that refers to any number that can be written as a fraction. Those are all considered rational numbers. More about a fraction. Every fraction has a reciprocal. The reciprocal of a fraction is the number that when you multiply it by the original fraction, the product is 1. The reciprocal is found by flipping the fraction. In this example, the original fraction was 1 over 3. The reciprocal is that number flipped, 3 over 1. When we multiply those two fractions together, 1 over 3 times 3 over 1, we end up with a product of 1. Right? 1 over 1. That's because 1 times 3 is 3. 3 times 1 is 3. 3 divided by 3, 1. All right, so adding and subtracting fractions. To easily add or subtract fractions, you want to have a common denominator. Right, the number on bottom should be the same if possible. We want the bottom number of the fractions you're adding or subtracting to be the same. When fractions have a common denominator, you simply add or subtract the values of the numbers, of the numerators. That sum or difference becomes the new numerator. So we have an example, 2 over 5 plus 1 over 5. We have the same denominator, 5 and 5. Turns into 2 plus 1 divided by 5, which is then just 3 over 5. So I add 2/5, I add another 5th, I have 3/5. And we can think of this operationally as just adding the numbers on top, while the bottom number just remains. Secondary example, we have 3 over 5 minus 1 over 5. We're subtracting this time. 3 minus 1 equals 2. The 5 remains on the bottom, and we have fifths. So we have 2/5. If I had 3/5 and I take 1/5 away, I'm left with 2/5. The other thing that happens when you're adding or subtracting fractions is they don't have a common denominator. In this case, you need to adjust the fractions to create common denominators. Then you simply add or subtract the values of the numerators. That sum or difference becomes the new numerator. So there's an additional step that we must take to be able to add or subtract fractions who do not have a common denominator. So let's look at an example. All right, so let's say that I want to add the fractions 1/5 plus 1/4. These do not have the same denominator, so I can't just add across. It doesn't work, and I can't add across and add across top and the bottom. I can't end up with 2 over 9. That doesn't work. So what I need to do is make these have the same denominator. And so what you need to do is find the smallest number that both the denominators are factors of. All right. So one way to do this is I can just start listing the multiples of each number until I get one that's the same. So we have 5, 10, 15, 20, 25, 4, 8, 12, 16, and 20. Oh, there's my same one. I have 20 here and 20 here. All right. So excellent. This is now where we can take our next step. We have a common denominator, a common number that both 5 and 4 are a factor of. So what I can do, say, okay, well, to get from 5 to 20, I have to multiply by 4. All right. So I need this over 20 plus the next number over 20 as well. So we're going to use our common denominator. Since I have to multiply 5 by 4 to get to 20, I also multiply the top number, the numerator, by 4. So I get 4 over 20. On the bottom, to get from 4 to 20, I have to multiply by 5. Right? Which then means I have to multiply the numerator that goes with 4 times 5. Right? 5 times 1 is 5. Now, I follow the same procedure as before. This will all be over 20. We have 4 plus 5 as the numerator, which will be 9 over 20. And there we go. We've now added two fractions that do not have a common denominator. Okay, so get a second example. Get some more interesting things going on here. So, second example here, let's say we have 3/8, and I want to add 9/2. Right? Once again, these aren't the same on the bottom. Let's look at common products, or not common products. Let's try to find a number that both of these are a factor of. So again, we're going to list our factors. We have 8, 16, 24, 32, and then we have 2, 4, 6, 8. Oh, there's my common number. So that means 3/8 actually doesn't need to change because 8 is the common denominator that I'm going to be using. So that means that we can kind of just rewrite 3/8. We have that one's going to be there, plus something else over 8. Right, to get from 2 to 8, I have to multiply by 4, which means I also have to multiply 9 by 4. That's going to give me 36. All right, and that ends up with 3 plus 36 divided by 8, which equals 39 over 8. It's totally fine to leave this as the fraction. We don't need to convert it to a decimal. We don't need to necessarily convert it to a proper fraction, unless you've been asked to do so. If you have, right, then you can write this as 4 and 7/8. The proper fraction. This would be considered an improper fraction at 39 over 8. Depending on your teacher, they may request a proper fraction, in which case you need to write it as 4 and 7/8. Otherwise, leave it as 39 over 8. Right, so this is just a couple examples of how to manage having a non-common denominator when you're adding or subtracting. Subtracting work exactly the same, except you would subtract across the top instead of adding across the top once you have a common denominator. And multiplying fractions, all right? So, we multiply a fraction, you multiply the numerators across the top, and the product becomes the new numerator. Then multiply the denominators across the bottom, and the product becomes the new denominator. For example, if I have 2/7 times 3/5, we'll just make a big division bar, and we say 2 times 3 equals 6. 7 times 5 is 35. The result is 6 over 35, or 6/35. We've also got, second example, 4/9 times 3/2. We end up with 4 times 3 equals 12. 9 times 2 equals 18. We can reduce or simplify this fraction from 12/18 to 2/3. And that's because 12 and 18 have common factors that we can kind of eliminate. And we'll go over that in a little bit. And so again, multiplying fractions is actually pretty simple as far as it's just multiplication. You just keep numerators in numerator spot, denominators in denominator spot, and go across the top and the bottom. When it comes to dividing fractions, to divide fractions, you multiply the first fraction by the reciprocal of the second fraction. Yes, that's why we brought up reciprocals earlier. We needed them. All right. When you divide fractions, you multiply by the first fraction by the reciprocal of the second fraction. Flip the second fraction, then multiply the fractions. So essentially, we turn division back into multiplication because multiplication is simpler. There's an example. 3/8 divided by 2/5 is equal to 3/8 times 5/2. Right? We flipped 2/5, turned it into the reciprocal of 5/2. We multiply across the top and across the bottom. 3 times 5 is 15. 8 times 2 is 16. We have 15/16, or 15 over 16 as our result. Right? So essentially, you flip and multiply. Again, we have 12/13 divided by 1/8. That then gets, the 1/8 gets flipped and multiplied. We have 12/13 times 8 over 1. All right. 12 times 8 is 96. 13 times 1 is 13. And we get a proper fraction of 7 and 5/13. Otherwise, this will just stay as 96/13. That doesn't have any common factors. 13 is a prime number, and so it is not going anywhere. All right. The only way we could simplify this is if 96 was divisible by 13, and it is not. All right. Simplifying fractions here. We've got a couple different techniques here that we can use. And simplifying a fraction means to reduce the fraction to its smallest equivalent fraction. There are two main methods of simplifying, using factoring or using greatest common factor. Right? Using factoring, first you factor top and bottom, right? Usually I like to see how many 2's can go into something. Because 2's, lots of things are divisible by 2. Cancel common factors, and then remultiply. So when they say cancel, it means if there's one on top and one on bottom, we can cross it off. Another one, another one. There are no more common numbers on the top and the bottom. I cannot cancel anything else. So we end up with 2 times 2 times 2 on top, 3 times 3 on the bottom. We have 8 over 9. Using the greatest common factor technique, we list out the factors, find the greatest common factor, divide top and bottom by the greatest common factor. All right, so we have factors of 32, 1, 2, 4, 8, 16, and 32. So literally anything that can divide 32 is a factor. Same thing with 36, we find all the factors, anything that can divide 36. 1, 2, 4, 6, 9, 18, 36. The largest number that both 32 and 36 have in common is 4. So we take 32 and divide it by 4, and that gets us 8. We take 36 and divide it by 4, and that gives us 9. And we get a result of 8 over 9. Right, so these are just the two most common ways of simplifying a fraction, which most of the time you're going to be asked to simplify your results or simplify your fraction. So you're going to need to know how to use at least one of these two methods. Right? And that's it. This is fractions and fraction operations, a basic review. If you have any questions, please put them in the comments, and I will see you next time. Bye.